In today's video, we're going to try to find x and y using the principles of congruency of triangles. Let's start by visualizing the problem. We have two triangles back to back. They've given us that angle B, AC, corresponds to angle B, ED, meaning they have the same angular measure. Therefore, we can start solving this problem by stating 40 degrees must equal 12x plus 4 y degrees. But notice there's two variables in there, x and y. So with two variables but only one equation, we cannot yet solve that. A good mathematical fact to remember is that if you are solving a system of equations, you need the number of unknown variables and the number of equations to be equal. Now, let's see what else we can do. Well, here we have a right angle, and this angle right here must also be 90 degrees because these are supplementary angles, and supplementary angles must add up to 180. So if this is 90 degrees and this one is 40 degrees, we can then figure out what this angle must be, because the angles of a triangle must add up to 180 degrees. So we can write 90 degrees plus 40 degrees plus an unknown is equal to 180 degrees, so that angle is going to be 50 degrees. Now, since this angle ACB corresponds to this angle BDE, they must have the same angular measure. So therefore, we can also say that 17x minus y must be equal to 50 degrees. Now we have two equations and two unknowns. We can solve those simultaneously. If I multiply both sides of the equation by 4, notice why did I do that? Because here I see a plus 4y and I see a minus 1y. So if I multiply this times 4, I'll get a minus 4y. And then when I add the two equations together, the y's will then be eliminated. If I multiply both sides of an equation by the same number, I do not change the equation. Now, I can add the two equations together. When I do that, I get 12x plus 68x, which is 80x, the y's are eliminated, equals 240. Now we can divide both sides by 80, and therefore, x is equal to 240 divided by 80, which is 3. So now we have a value for x. Then I can plug that back into one of my two equations. It doesn't matter which one I plug it into. So I'll take this equation, and instead of writing 12x, I'll write 12 times 3 plus 4, y equals 40. 12 times 3 is 36, so 36 plus 4, y is equal to 40. Now we can subtract 36 from both sides, so I get 4, y is equal to 40 minus 36, or 4, y is equal to 4. And of course, divide both sides by 4, I get y is equal to 1. And so, there we go. X equals 3, y equals 1 is the correct answer. If you want to check to make sure you have the correct answer, you can take both x and y and plug those values into the other equation just to see if that is indeed correct. So, 17 times 3 minus 1 equals 50.